Hello again. First, a quick update on the radio-controlled lead-out guide I made in my last video.
I should have used a number 4 threaded rod for the jack screw. The number 2 rod bends too easily.
Now let's look at a mechanical solution. This is not a radio-controlled lead-out guide, but it is still a remote-controlled lead-out guide. Remote in that I make adjustments via full-down control at the handle.
This is a simpler solution. There is the combination rib/guide track and rubber band, the combination sliding lead-out guide and escapement, a spring, and a triggering cord. The wingtip rib is made of 1/16 plywood. It also serves as the lead-out guide track, making the overall solution easier. There is also a hook at one end and a hole at the other. An escapement is a mechanism usually found in a clock. I call this a linear escapement because it is flat and functions in a similar way. It is made of 1/16 plywood. It was easiest to carve the teeth in 2 pieces and join them together afterwards. I added additional strips of wood to give it strength and joined it to the sliding lead-out guide. You can also see the addition of a hook to be used later. The sliding lead-out guide is held to the track using 3 eyelets. The extra eyelet is there just to help with the tracking. It is the forward 2 holes that are used for the control lines. Of course, in a real application, the eyelets would be glued in place. The triggering cord goes on the spring, and the spring is inserted into the escapement. The spring is then secured with a number 2 screw through the hole in the rib. The rubber band is installed between the sliding lead-out guide and the rib. It provides the energy that moves the lead-out guide rearward. The main advantage of this solution is that it weighs only 0.3 ounces, a weight penalty of 46 seconds worth of fuel. The other end of the triggering cord is attached to the up arm of the bell crank. Each time full down is given, the lead-out guide triggers back 1/4 of an inch. This mechanism gives 1.5 inches of total movement.
There are a few obvious problems with this lead-out guide.
The triggering cord should be attached closer to the end of the spring to get a more assertive trigger. One rubber band may not be enough to pull the lead-out guide back solidly, but too many rubber bands will prevent the trigger from firing due to increased static friction.
Also, the rubber bands might not be strong enough to overcome the natural forces of the control lines on the lead-out guide.
There is considerable play in the escapement that must be eliminated by the rubber bands. And I should have used 1/8 ply for the rib to keep it from bending. Another obvious disadvantage of this lead-out guide is that it will only move rearward, not forward.
The worst part is the escapement. It shouldn't be made of wood. It's so unreliable. It needs to be brass or stainless steel, but I don't have the tools or skill to fabricate the part with any precision at all.
Unfortunately, I don't think this particular design qualifies for actual use.